so here we go. We're going to take the derivative of number 7 implicitly. So we take the derivative of x, which is 1, plus the derivative of tangent of xy is a composite. So we have to take the derivative of the outside, which is secant squared, keeping the angle argument, times the derivative of the inside, which is a product. So we have to use the product rule. First, which is x. And what's the derivative of y?
dy dx.
dy dx. Good. Plus second, which is y, times the derivative of the first, which is at 1, right? Equals 0. Now we've got to solve for dy dx. Now this is a little bit messy than we're used to because we have to distribute this first in order to separate the dy dx.
Oh man. Yeah, no, that's what
So we're going to go 1 plus, so this is going to be x dy dx times secant squared xy plus y secant squared xy. Now why do I just put the things we're multiplying by a trig function in front to keep them separated from the angle arguments. Okay, equals 0. And now I have to move the things that don't have the dy dx in them to the right side. And I'm going to factor out a dy dx, and what's left, which is going to leave us with x secant squared of xy equals negative y secant squared xy minus 1. And the next thing is we divide both sides by x secant squared xy. So negative y secant squared xy minus 1 over x secant squared xy. And there's your answer. So the only trick on this problem is that you have to, once you do the product rule on the outside there, you have to distribute the secant squared xy to be able to separate the dy dx out. Okay? All right, next one. I'll rewrite it so everybody can see it. Yep.
I just have a question about the last one. How did they get this answer in the book?
All right, let's see what the answer in the book says. What does it say?
Negative 1 over x cosine squared of xy.
Is this multiplied? Let me look at it.
Yes.
And then what?
Minus y over x.
Minus y over x. Okay, what they did was they divided this into this, because what happens when you divide that, you get negative y over x, and then they divided the one, this is what they did. They did negative y secant squared xy all over x secant squared xy minus 1 over x secant squared xy, right? And this cancels, and so you get negative y over x, and then what is 1 over cosine? So this is negative 1 over x times cosine squared of xy. So it's equivalent.
Okay, I was just wondering.
And I would accept either answer, obviously, but
Okay, thank you. Why make it harder?
yeah, that's why your answer might not match, actually, right? All right, so is this x cubed on number 13? Or is it x squared?
X squared. Squared, sorry.
It's x squared y minus xy squared equals 4. So we have to do how many product rules?
2.
2.
This is so terrible.
We are excited. Okay, so it's going to be first. Help me.
Second. First, second. 2x.
X squared. What's the derivative of y?
1.
No.
dy dx.
dy dx. Is that pizza? Is that pizza?
No, it's a cookie.
It looks like pizza from here.
Yeah, it does kind of, because the
Does it?
wrapper. Yeah, because the wrapper. First,
Plus.
y.
I thought you were saying
plus
something as big as
times
y.
y times 2x.
Oh gosh.
Sorry, it will look too enticing. Sorry. Okay, so now what I do when I'm doing the second product rule here is that I use the first as negative x, so I distribute that pesky negative. Okay, so the next product rule is going to be first, which is negative x, the second, which is 2y dy dx, right? Power down function over the power 1 times the derivative of the inside,
So you
which
put,
is,
but you put y and dy dx?
well, what, okay, so what's the derivative of this? If you weren't worried about it, I mean, that's,
Oh, y squared?
yeah,
2y.
there we go. So remember, we're doing this, try again, one more time, f of x quantity squared, right? Because that's y, right? I mean, that's y squared, that's the same thing as saying that. How do we do it with the chain rule? We would say power down
Oh, multiply
Function.
by f of x.
times the derivative of the inside, which
Okay,
is
okay.
f prime of x. But what is f prime of x? It's
dy dx.
dy dx, you see.
So why,
For the first one, derivative of
I know.
y is 1.
I know that, but it's why. I don't understand. Why do you have to do the chain rule for that one than with the other one you just said like y, 2y?
Okay, what's the derivative? Let's say if we have y, what is the derivative of y?
1.
Okay, but what is the derivative of x? F prime of x, right? What's another way of writing f prime of x? dy dx. Do you see that now? Okay, so anytime you take the derivative of y all by itself, this is going to equal dy dx. And think about it, you guys. I mean, we've been doing this all along, and I'm using 3x plus 7. What's the derivative of this? You go dy dx equals what? 3. We've been doing this all along. When you take the derivative of y, you just didn't realize it.
So we're getting it to that point.
All right? Oops. I just so like that I can do this. Get it out of the way. Okay.
Yeah, I wish we could do that.
I know, sorry. Okay, so we went first d second, right, because the first is x squared. The derivative of the second, remember the derivative of y is dy dx, plus second, which is y, right, times the derivative of the first, which is 2x, minus x is the first, times the derivative of the second, which is 2y dy dx. Now where are we? Plus, or minus, or no, plus, because of the product rule. The second, which is y squared, times the derivative of the first, which is
1.
no, negative 1.
Negative
See
1.
how this equals the derivative of 4, which is 0, right? See, so that's why I choose the first one as the negative x, because it's first d second plus second d first, and the derivative of the first is negative, and you've distributed the negative successfully. You all right, Tricia? dy dx. Multiplying, what do we get when I factor it out? Because we're solving for dy dx.
Yeah, x squared.
We get x squared minus 2xy equals, now I'm going to take the other things to the other side, the other term, so this would be y squared minus 2xy, and then dy dx here is y squared minus 2xy all over x squared minus 2xy. Now, it looks very tempting here, doesn't it, to cancel, but you're not going to do it. Right?
What's wrong with cancel?
It says, cancel me. No, don't do it, right? Here we go. Hmm?
Is there a Taylor Swift song for that?
I need a song, don't I?
Yeah, Make It Friday.
All right. So this is y equals x times x squared plus 1 to the 1/2, right? I'm assuming the instructions on this are find the derivative?
Yes.
So, what rule do we have to use?
Power.
Power
And
chain.
first to second.
Right, so we have to use the product rule and the power combined with the chain. So we'll say dy dx equals first, d second, but what is the derivative of the second? It's a power combined with the chain, so it's going to be power down,
And then times
1 half x squared plus 1, lower the power 1
negative 1 half.
to the negative 1 half times the derivative of the inside, which is 2x. Plus second, which is x squared plus 1 to the 1 half d first, which is gloriously 1, right? All right, so let's simplify. Now, this x, or this 2 and this 2 can cancel, and now I'm putting things where they belong. So, what's on the in the numerator? X times x, so we get x squared up here over square root of x squared plus 1 plus the square root of x squared plus 1. I don't know how the book left their answer.
Well, now we have to find the second derivative too.
Oh, we do.
Oh wait, never mind. That's in different ones. Oh wait, never
Did
mind.
the book leave it in this answer?
27
Which
others.
one is it?
No, it's not. It's
There
not.
are
Just
several
one
directions for
derivative.
this, or just find the
Oh, wait.
derivative.
Caroline, don't let Luke confuse you.
Hey, Caroline.
We could, though, take the second derivative if we needed to.
Well, we don't need to. That was in like the ones before.
Makes your hair feel good.
Yeah. We're not gonna do that.
Imagine taking the second derivative.
Yeah, they didn't put it into a fraction. They just left it with the negative exponent. But we don't like that.
Right, now, if I'm not happy with this because I want it with a common denominator.
What?
I know,
Oh, it's equal. Just do the second one and it pops
what is
out of
the
the
common denominator here?
root x squared plus 1.
So this is root x squared plus 1. This one I don't have to do anything to. What do I have to multiply this by?
Root x squared plus 1.
Which does what?
Pulls it out.
Plus x squared plus 1. Takes the square root off.
2x squared plus 1.
2x squared plus 1 over the square root of x squared plus 1. And if I had to take the derivative again, which is the better form? This one. You see? That's the way I would prefer you to leave it, with the common denominator. So this is y equals the square root of 1 minus the square root of x. What do we need to do here? Change it to exponential?
Yeah.
Which is going to be what?
Parentheses.
1,
1 minus x to the 1.
1 half, raised to the 1 half. And no, we cannot distribute that exponent. Don't do it, because there's a plus sign right here. All right, so dy dx here is, you can
So
distribute
bring it
the
down.
exponent over multiplication and division, but you cannot distribute the exponent over addition or subtraction.
Okay.
Okay?
Can I try this one?
Sure.
Alright,
Please.
bring it down.
Bring it down. Here it is.
Bring it down.
Then you do 1 minus x to the 1 half times the derivative of the
Well-
inside. Okay.
Power down function,
Subtract 1, so it's negative 1 half.
negative 1 half. Good.
Then you multiply by the derivative of the inside.
Which is?
0
Uh-huh.
minus 1 half x and minus 1 half.
To the minus 1 half. Good. All right, so let's put things where they belong. I have a 4 in the denominator, right? 2 times 2? What else is in the denominator? Everything,
Yeah.
right?
So,
So this is to the negative 1 half. So this is going to be the square root of 1 minus the square root of x. Do you agree with that?
Yeah.
The bottom times. I'm going to put 1 up here, negative 1. And then this is Square root of x, right? Are these the same root in the denominator? Meaning the square root of 1 minus x is 1 minus the square root of x times the square root of x? And when you have two things that you're multiplying, the properties of radicals say you can do what? Multiply it in.
So that's going to be square root of square root of x minus x.
Square root of square root of x
Oh my goodness.
Minus just
Minus
x.
Wait, what is
minus
B?
x.
Oh, okay. Oh, that kind of makes sense. Wait.
Wait, what? Help me?
Can't pull it out because you don't have x squared.
Would it be x?
This is root x minus x. Because what's root x times root x?
Where are you going?
Doctors.
Have fun.
Thanks for coming for half an hour.
Yeah.
Wait, would you
I knew it. You told me early. What?
Yeah.
Did you know the multiplying x?
Are you playing? Are you gonna play music today?
Square root of
Oh, yes.
Yeah, that's
Okay,
why I
okay.
came in for 30 minutes.
Hey, don't worry,
I
we're
was
recording
like-
it.
I'm sorry.
Hey, Caroline. Hey, Luke. Hey, Luke. Hope you're having a good day when you're watching this. Okay.
Oh wait, what?
If you were tired, just put it in 2 times.
I need to
speed.
rewind the tape. Caroline, sorry.
Listeners while I talk really fast, it's really funny.
Hi, Caroline.
Wait, how do you get? How did you get?
Because I'm bringing the x in. I'm not bringing square root of x in. What I did was this. Do you know what I'm saying? I brought that in instead of this root x. That was my first mistake.
I was
Wait,
very
what?
confused.
Yeah, I kind of understood it when you did it the first way, but now I'm
Now you get it,
not
which is good.
understanding it.
Now you're not?
No.
Okay.
What?
What happened here when I did the square root of a times the square root of b?
A times B.
It's a times b.
Not.
I'm not bringing the square root of a under, right? So I'm bringing just x under.
Oh, I got it.
Okay, that was my bad. Thank you, Nathan.
Yeah, I was like, well, that made better sense when you did it.
Wrong way.
All right, here we go. It's early, right?
Right. It's always really.
What is this? Y equals 3 cosecant. To the 3 halves.
I think you forgot one.
Do I have to take the second derivative of this one?
No, you don't.
dy dx. It's
Power
Friday.
down.
Power down, which means
3
9
times.
halves.
I was getting there. Skylar was laughing at me. And then
Function, lower the power 1.
1 half.
Times the derivative of the inside, which is?
Negative. Yeah.
Whoa, terrible. Turco with the moon.
Okay. So this is 9 halves. What is the power on this cosecant? It's 1 half. What is the power on this one?
1.
So can you add them?
No.
Yes.
What? So this is going to be negative cosecant to the 3 halves x
Oh, because
cotangent x.
Why is it negative 9 halves? Oh, right.
Max. Charge.
I think you forgot a letter.
All right, we got it?
I did too. I was like, Griffin, what did you just say?
It's this thing we learned in middle school when adding and subtracting
Excellent.
exponents. Mads if you're multiplying and you add.
Mads.
If you're dividing
That was
and
good.
subtracting. That's good.
Nice. Which of the following could be true? Does that say f prime or f double prime?
F double prime.
They're saying f double prime of x is equal to x to the minus 1/3, right? So, what I would do here is how do I find f double prime?
Take the
First, you take the first one.
First you take the first derivative, and then you secondly take the second derivative, right? So, the first one is 3x squared, 3 halves x to the 2/3 minus 3. So let's take the first derivative.
What?
Is there a way to
What's the problem?
For C is F
We have to-
triple prime.
What?
For C is F triple prime. How do you go back?
Okay, well, I was just going to go one at a time. Is that all right?
That's perfectly okay. Let's do that. I'm just kidding.
derivative, right?
Her going
So this
gotcha.
one doesn't work. B says f of x is equal to 9/10 x to the 5/3 minus 7. What's f prime of x here?
45.
3/10? No, 3/2. 3/2 x to the 2/3. So what's f double prime?
Oh, we already figured this one out. It's the same as the top.
Well, but I haven't figured it out yet.
It's the same as A.
X to the
Same
minus
as A.
1/3. No,
So
it's
it's
not,
one.
because this is f double prime, not f single prime.
Yeah, I know, but I meant you didn't have to do the math again.
Oh, no,
because
no,
they
okay.
match up.
But B works, right?
Right.
All right.
but more than one can work.
Yes, so what's C here? F triple prime of x is equal to negative 1/3 x to the negative 4/3. Okay. That's the third derivative. How do I go backwards?
Oh, you just take
Add one.
you just
Okay, good. Add 1 up here.
Yeah, so that's 1/3.
Negative 1/3.
Oh, and then you take that away
divide
because
You have to
when you
divide.
bring that down.
What I said was
Could
right.
you just
and
get
what
the
you
third
said was
derivative?
No. Going forward, you would bring that down. So yeah, you would.
Are we
So
done?
that
You
just
just put
verifies
it-
the
yeah.
1/3 by 4.
So
No,
it's
you can't.
No, that just verifies
Oh, you
what
can?
was there, right?
Are we done?
I don't know.
If y equals
Don't you divide
x to
that
the
with
n.
the
Wait,
exponent
I know that we're
That's what
excited.
you have to bring down.
And what's dy dx here?
I think.
N x to the n minus 1, right? Listen, I appreciate that this has got everybody so excited. But what did I do? I brought the power down and I multiplied and I lowered the power 1. If I'm going to go backwards, let's say I have my derivative is x to the n. I'm going to raise the power 1 as you guys so aptly stated,
Are
right?
we done?
No,
No, then you have to-
And then instead of
divide
multiplying, you
by
divide.
and
your new in.
Ugh.
But why
So
would
it's
we
right.
divide?
So it's done.
But you're not done yet because we multiplied in this case, didn't we? And we're
then
going
yeah, and then
backwards.
1/3 divided by negative 1/3 is
1.
Hold on a minute, just relax. Plus c.
some of us aren't there yet.
All right, deep breath. What happens if I take the derivative of this?
Of what?
Power goes down, right? So the n plus 1 goes in front. Function. Lower the power 1. So it's going from n plus 1 to n. And the n plus 1's cancel. So do you get the same thing? Should I try that again?
So
So
the
you-
same is going from the second derivative to the first derivative
Yes.
as well. So it's always the same thing going down.
Yeah.
Okay, so we don't have to remember any of that. We just have to write the same thing. Or like remember.
No.
You would do the same process for
Yeah.
yours.
Like well, like if it's the same thing, then what do we have?
You have a function and you have the first. And you'll hide them function.
Right.
No, we just went from the second to the
Negative.
third.
So go from the function to the negative derivative.
So what happens here? What do? You raise the power 1 and you divide by the power. Instead of bringing the power down, multiplying it.
Okay.
No. Was that the last question?
Wait, wasn't it f to the
Yeah, that's the
negative?
last one.
I mean x to the negative 1/3.
Yes, it was, but I was listening to everyone else.
I'm not upset with you. Oh. Oh.
Right? I'm suggesting to you that this is going to be what happens. You raise the power 1. Everybody gets that, I think, right?
Yes.
And then you divide by this power instead of multiplying. Because what happens when you...
Oh.
Now let's just take the derivative of this, pretending we don't even know where it came from. Let's say we have 1 over n plus 1 times x to the n plus 1, right? If we were going to take its derivative without remembering what we did to get it, what is divide by that power. They call that the anti-derivative. Now, you must put a C here because could there have been a constant?
Yes.
It could have been plus pi, it could have been plus 7, it could have been plus root 2, it could have been plus e.
So do you always put a plus C?
You always put a plus C when you're going backwards.
So you can have
Okay.
two.
Right.
Um,
And I call that C the cupcake because
No.
I heard wait.
Oh,
We're
yeah,
gonna have
sorry.
to know
So
this.
would that final answer be x to the n plus c? Like you
No, it's a derivative of constant.
Denise said that they wanted to find the cupcake.
Oh, you were going to.
Yeah, right?
I got it.
wait, how can you call it the cupcake?
Because teenagers like cupcakes and they don't forget them.
Or cookies.
Are we eventually gonna have to know how to find
I
the
love
cupcake?
Yeah,
Denise said it's gonna be
absolutely.
Oh,
Okay, so we found out that C
This is
worked, right?
foreshadowing Rasmus.
What's D?
No, it's just blatant.
There's no mystery.
Sorry, I like
F prime of x is equal to
3 halves x to the 2/3
3 halves x to the 2/3
plus 6.
plus 6. What's F double prime here?
Derivative.
Which is power down.
1x minus raised to the negative 1/3. That's it.
That's it. Does it match? So B, C, and D are winners.
Wow. What is the worst multiple choice question ever? Is where do you like this problem? Should have just said which one does not work.
No, but you didn't put 41 on here. Or 39, did we?
Yeah, we did. Maybe 41 was, I don't think
We just finished, this was 43.
We did
Oh.
39 and we did all of it. Yeah, we did all
Oh,
of it.
okay, I'm
39
sorry.
was the
I'm sorry.
square root one.
It works.
You guys are very chatty today, which is not a bad thing. It's just I'm not rolling with it as well as I usually do. Which is not your fault necessarily. It's Friday, right?
Great.
All right, so I have to tell you guys a couple other things about implicit differentiation. Ready?
You have to tell us what? Oh.
Two other things.
Oh, yeah.
Are these like notes?
Mhm. Impulse, well, we're going to impulsively do implicit differentiation.
Oh, man. That's what I like to do.
Okay. So, what is our favorite circle?
Unit circle.
Unit circle, right? What was the equation for that?
Circle for x.
Y
X
squared
squared
plus
plus
x
x
squared.
squared.
What?
Okay,
Why
same
did you do
thing.
y squared first? It matters because you messed me up.
Well, it really doesn't matter, but
It's
You messed me up is the point.
So it's all you, not team player.
Yeah. Math is an individual sport.
All of them are the same scale. You just have to stress it.
Mushroom, unit, and like
so like I said, our favorite unit circle is x squared plus y squared equals 1, okay? Now does this have, this is a circle, right? With a radius of 1 and it has tangent lines to be found. Now we're going to take the derivative here implicitly.
Okay.
So how do we do that? We say
2x
2x plus 2y dy dx. Good. Equals 0. 2y dy dx equals negative 2x. dy dx equals negative x over y, right? Well, guess what? We can take the second derivative of implicitly defined functions. Okay, so this is the first derivative, but let's say you're asked, as you will be in tonight's homework, to find the second derivative.
Okay. Hello.
Well,
Still a quotient rule?
we take the derivative of the first derivative, and that's the notation. You put the little 2 in between the d and the y.
Why is
because they don't want you to think that you're taking the derivative of y squared. Now, I don't know why they didn't follow suit when they created this notation and
That
put
is
the 2
very
in the middle.
annoying.
It is, but that's the way it is.
That is very
They're gonna
annoying.
have to-
I'm not writing it like that. I cannot. That is very annoying.
Anyway, so now we're going to use, as Griffin suggested, the
Kelly,
quotient
say
rule,
hi if you agree.
right? Which is ho
Ho,
y d high, which is
-2.
negative 1 minus high, which is negative x, d ho, which is good, dy dx, all over ho ho, which is y squared. Now, that's the second derivative, but
The first derivative is in the second.
the derivative, first derivative is inside of the second derivative. So I can just take this expression and do what with it?
Plug it in.
So
Plug it in.
Aw.
It is cool.
This is like people trying to be creative.
It is, we are creative. All right, so 1 over y squared, I'm going to pull out in front because we're about to get a double-decker fraction. So this is negative y plus x squared times, I'm sorry, plus x, I'm sorry, plus x times my derivative, which is negative x over y, right? That's all I did was bring the 1 over y squared in front, which is nothing new. And then we're going to go 1 over y squared times, let's simplify this a bit, we get negative y minus x squared over y. Everybody solve that? Now I want to get a common denominator inside. 1 over y squared times y in the bottom here. So negative y squared minus x squared. And then I'm going to factor out a negative 1 over y. Right? So I'm going to get negative 1 over y cubed. Everybody follow? And then what's left on the inside? Y squared plus x squared.
Which is over here.
But we're going to, yes, I want the thought bubble to happen. But wait. But wait. From the original problem statement, what does it say?
What the heck, me?
X squared plus y squared equals 1. So we come back down here, and we say that x squared plus y squared is equal to 1. So we can replace this with 1. So the second derivative is nothing but negative 1 over y cubed. Now, let's pull your calculator out, if you will.
That's pretty cool.
Yes, it is very cool. Pull your calculators out. I should probably do this on mine, too.
There's more. Everybody get your bread.
No, I didn't bring my calculator. All right, so I need somebody to come over.
Share.
I can.
You're the hacker.
No, I did. I brought it. You want to use my calculator? Somebody need a calculator?
I do.
Here. Oh, well, come over here and operate.
Something like that.
question, did it match what we had?
That
Yes.
was. Yes.
I know.
Sorry, I'm always like.
So yes, this matched what we had up here. Oops, I didn't mean to move that one. Of course, right? So we're happy about that, right? It matched.
Yep.
Now, how do we find the second derivative?
Comma 2.
Okay, so we're going to take our calculator and we're going to hop down inside the parentheses and go comma 2. Press enter. Now,
This one.
that looks vastly different, doesn't it?
Yes. Very vastly. Oh, nugs.
Now,
On nugs.
Yeah.
I'm not saying that.
Did they just not do the x squared plus y squared
Oh,
equals
no,
1?
it's the
On
same.
nugs.
Because if you find the
this is a very powerful statement. This is what the calculator got, right? They got negative x squared over y cubed minus 1 over y. What happens if you find a common denominator here?
They find y.
You get y cubed on the bottom, negative x squared. You multiply this by y squared over y squared, which is minus y squared. Now, the calculator, even as good as it is,
It's negative 1.
cannot do what?
Plug
The
that in.
thinking part.
It's supposed to think
Because it is a
Right.
machine, and you have to do the thinking part, which is what God invented our brains for. It's the thinking part,
Make
right?
things like this.
Well, I mean,
So,
initially you invented them
this
for,
is
like,
on-
knowing this stuff.
You know what I mean, right? God, that we are a well-engineered machine in his design, so I'm honoring him when I say it. Okay? I think I do. But this, you have to. What happens is on the calculator section of the test, it's going to say find the second derivative, and guess what answer is going to be there? This one, not this one. But does this one at least get you to where you can find a common denominator and do the thinking part?
Wait, are you saying, like, you're going to give us a problem and then we're going to have to, like, simplify what answer the
Yes.
answer gives us?
Yes. Okay? So, finding the second derivative. Could I find the third derivative?
If you want me to.
Yeah, just do comma 3.
Let's do it. Let's find the third derivative. Well, not yet on the calculator. I'm doing it by hand first.
Oh, okay. But so do you do the quotient rule?
That sounds cheated.
Okay. Okay, I know.
Here we go. What's it going to be?
You said you rate me so much, too.
Remember, we could use the quotient rule here, or we could rewrite this as negative y to the negative 3, right?
Oh, which one is y to the negative 3? That's so much easier.
So much nicer. So what would that derivative be?
3
3y to the
dy
negative
If
what?
4.
4.
Why?
What's the problem?
Why?
Why?
But seriously, why?
I know.
Right. But like, why do you actually? I can't make it not be a joke because I have to use the question word why.
Okay.
But why do you
How
have to also? Yeah. How come you have to put the y in front and put dy dx?
Because y is an implied function of x that we don't know. Remember? I'm going to have to say it a lot of times.
I know. Like you
It's
wrote it
okay.
out.
It's okay. What is y equal?
When you write it out, it makes sense.
Okay,
but
I know.
It's like
What is
it's
y equal?
f of x.
F of x. I am here taking the derivative of
F.
f of x
Of x.
to the negative 3.
So.
So,
Yeah.
right? What is that? That's going to be,
A negative or positive.
I'm sorry, hold on.
You're such a Okay. So it's gonna be positive
3
f of x times the inside times f prime of x. And then the derivative of
And what is the derivative
is
of
f
inside?
prime f prime of x
Which is,
dy dx.
yes,
But why? Stop saying that.
because we don't know what y is. because it's been implicitly defined.
Oh, right.
So we're using a placeholder.
It's kind of getting a little less foggy.
Okay.
Because we don't know what x is, but we can do negative 3x.
But x is the independent variable. Y is dependent on what x is.
But in the original equation,
right. So
x
this is
squared
y 3 over y to the 4th times dy dx. But wait, do we know what dy dx was?
It's negative x over what?
Right? Which is negative 3x over y to the 5th.
That's fine.
Yes, it is.
It's not. I'm probably gonna have to have you do that like once a class.
It's all right.
I'm gonna come.
Just notice how patient I am because that's what I need to be. That's my job.
I appreciate your patience.
Okay, so she's going to now do it on the calculator, right? And make that comma 3.
Man, it's not that good.
All right, but
X
what do
squared plus y squared
what do
is
we
one.
know? Yeah, see now the calculator's starting to be our friend a little bit here. So the calculator has now made the thinking thing a little bit easier for us, right?
Thank goodness. Because I don't know why.
All right, has everybody got that you can take multiple derivatives?
Yes, ma'am.
All right, and this is equivalent. Why? Because
This is fun because x squared plus y squared equals
Because this x squared plus y squared equals 1. Yeah. Okay? And we could keep going, but I don't want to do that as far as derivatives. I mean, we could keep going derivatives to the 4th and all of that, right? Now, there's another thing that we need to do, is we need to find horizontal and vertical tangents.
So just
Okay.
second equal to 0.
So, let's do another example here.
Why do x equals 0?
What? Y equals 0. No,
Oh, I
come on, my mouse was
She looks so official after that.
Do you need me to do something first?
I'm going to go and let's get an actual AP problem.
No. I'm not ready for this.
Yes, you are.
What block does your
Cartoon.
pre-calc class have their
It's
test?
What?
What block does your pre-calculus class have their test?
Next. Yeah.
I'll write them a note.
Yeah.
Okay.
Yeah, just like leave it on the board.
What's their test on?
You will live.
It's their trig equations and
I'm just gonna
Oh,
wait
yeah.
here actually and give Mary a hug before her test.
yeah, she's freaking out.
I know.
Who?
Mary Marquardt is
Oh, she's in
very scared.
on her?
Yeah, not scared, but nervous.
I didn't know that.
Because I'm so mean.
She doesn't see that.
I've been telling her that.
Julia, what did you say?
I'm just kidding. You have a lot of files.
I have so much
That was so extra.
I don't know how you did it this far.
What? No,
It's a lot of effort for
What?
You were very organized.
I'm looking for, I know.
What?
Mary Marquardt and her test text. And I was gonna say, here, give her up for the fourth test because she's freaking out.
1985? Oh, 79.
We're going to do more part ones. All right, so these are the free response questions from 1979 to 1988. So let's see if we can find an implicit differentiation one to do.
Did
So
you take AP Calculus in high school?
I did.
Can we look at your AP test?
Yeah, then I'd have to tell you what year it was, but.
Well, you don't have to tell us. You can just like pull it up and scratch out the date.
Yeah, we can all do one of those
I
turnaround
all know
things.
how old I am anyway.
Did you get a 5?
Okay, hang on, I'm trying to find an
Julia,
diff.
27, right?
Yeah. That'd be really nice, but.
Wait, this is 200 pages.
Oh,
flatterer.
29.
79 to 88.
200 pages of calculus.
Let's do every single one.
Don't even joke.
The nerds on, whoops.
That hurts the
There's
soul.
so many piece of problems on there, so
The nerds do all of
This
them?
is the study guide for platform screens.
I think that's
This is hard for a first one.
Like that's one of those things I don't cringe at because I'm like, I can't read it.
Oh my gosh.
Some of these
Looks
I
like
just
foreign
don't even
language. I
know
don't
where
think
it is.
Some of these I'm like, we're gonna have to learn how to do this.
I
We
do
can
that.
This is terrible. But then I see that it says BC and it's okay.
You know, but you're not ready for all of this yet.
Oh,
So
I know.
don't-
Yeah, we're not ready
for
much of
It's not
anything
going to
yet.
be as scary when you get there.
Page starts.
I mean, scary might not be the word.
Frightening.
Terrifying.
Actually, if you try to explain derivatives on the first
I
page,
took it,
I don't get the
in
table. What is that?
1987.
Oh, do you remember it?
What?
Do you remember them? This is actually yours? This is the one you took?
Apparently Cody's back.
Were you in BC or AB?
Because they didn't have BC in my school.
Okay, but point is that we can all be as great as this one. Did you have by default you were in the same class that we're taking?
Okay, where's my gift coming? I'm waiting.
These are all BC questions. Okay, there we go. Oh, I think that was purple.
This, I feel like, since it's not shown yet, this like,
This just is a sign.
yeah, like, it's
Wait,
not
I
going
saw
to be on the exam. So why?
What if the exam was 208 pages?
Oh my.
How many pulled you out of that room? She's like, well,
No, it's from the years
I already-
1979 to
'cause
1988.
I know,
Yes,
I
that's
get
how long
for
you're taking
your
it.
spot, you're taking
It's a 9-year exam.
Okay, wait, so
You
just
All right, so let's try to do 1987 BC 2.
How much money do you have?
Just start a new page. It's don't even.
Okay.
All right, so what's the equation? It says y cubed plus 3x squared y plus 13 equals 0, right?
3y.
So it says the first part A says find dy dx. Well, so even we got this, right? So what is the first derivative? It's going to be 3y
3y
squared dy dx, good. Plus, now we're going to use the product rule, right? So first is 3x squared times the derivative of the second, which is dy dx, plus second, which is y, times the derivative of the first, which is 6x, plus the derivative of 13, which is 0. So this is equal to 0, and then we're going to solve for dy dx. So let's do that. We say dy dx, I'm going to factor out, and we get 3y squared plus 3x squared equals negative 6xy. So dy dx is equal to negative 6xy all over 3y squared plus 3x squared. Here we go. Now, could we reduce that by 3? So let's do that. Let's reduce that by 3. And so we can get dy dx then is equal to negative 2xy over y squared plus x squared.
You couldn't do the one thing.
No, because because what's equal? What do we know? We know that's equal to 0.
Gotcha.
Yes.
So on the national exam, if we had just kept the 6 and 3s, is that
Yes,
point
they would
off,
have
or
given
is
you
that-
credit for that. But back in 1987, they probably wouldn't have.
It's much nicer to
Oh, I don't know how you did it.
They mean in 1987?
No, they just
They have BC to differentiate.
they wanted you to be able to reduce
No, she
things.
just said her school didn't have BC.
No, we didn't have BC.
But like BC still existed, right?
Yes, it did.
Jeez.
We only had AB. All right, so this
But we're getting there.
part B says write an equation for the line tangent to the curve at 2, -1. Could we do this?
Yeah.
All we have to do is say part B at was it 2, -1? 2, -1. What is dy dx? Dy dx is, well, it's going to be negative 2 times 2 times -1 all over y squared, which is 1, right, plus 4. So that's going to be on top 4 over 5. So what's the tangent line going to be? Y plus 1 equals 4/5 times 6 minus 2. There you go. Yes?
Well, you might have already said this, but I might have missed it. Do we not make the denominator 1 on the derivative?
Okay, yes, we did a problem last time where the original problem statement said x squared plus y squared equals 1. But do we have that statement here? so we can't assume that.
Okay.
What was he asking?
He asked, we see the x squared plus y squared, you know, we want to put 1 in there because we just did a problem where it was x squared plus y squared equals 1. But that's what we took the derivative of, right, Robert? And so we took the derivative of this. So if I saw this expression, I could replace it with 0.
Okay. Thank you.
All right? Okay,
That'd be
part
terrible if you got that.
Part C says, find the minimum y coordinate of any point on the curve.
Hey.
We're not ready to do that part. But we could do A and B. Is that okay?
Wait, what? I have no idea what that means.
How would you even approach this one?
Right, but that's okay. I know. A, B. Haha, funny.
All
All right.
Maybe not.
So let's do another one. So we could get a 6 out of 9 so far on a BC question.
Yes. I consider that a win.
That is a win. All right, so I'm going to go
That's
here.
a passing. That's a 5.
Yes, it is.
That's a 5. We
All
just
right,
got 5
so
out of
let's
the BC 12.
keep going.
I mean, just put me on the wall. They have a lot of hard motion problems.
Everybody, you're going to have a particle motion problem. And ABs have particle motion problems too.
Thank goodness. Observed, we're gonna be like the best. Wait, when are you gonna get observed? Who will come observe you?
Mrs. Reagan or Mrs. Lancaster, either one. But I'm all right with that. I just
Me and
don't
Miss
want to-
Lancaster are so tight. Yeah. I hope she observes you.
All right, here we go.
She gets so excited.
Oops, I didn't mean to do that.
So like anybody else? Bye. Okay.
All right, this is from 1978. But this one was on the AB test and the BC. You know this? So we should be able to do all
Wait,
of
does that mean it was 5 points for the AB?
Well, no,
No.
it was the question.
the
5.
question 5, but BC 1. All right, so part A says find the general expression for the slope of the curve, which means it's dy dx, which we're trying to find. All right, so it's x squared, so the curve, I'll put part A here, is x squared minus xy plus y squared equals 9. So we're going to try to find the derivative. So let's take this implicitly. We get what? 2x minus first dy dx, which is second, plus second, which is y times the derivative of the first, which is negative 1, plus
2y dx.
2y dy dx
Why?
equals 0.
Oh, actually, I do have a question.
Oh, okay.
Okay, how come you only put the y when there is an when there's an exponent higher than 1? Like in xy, when you found the derivative of that.
I went first, d second,
Right,
the
right,
derivative
right.
of y is dy dx.
So you only have to add the y if the exponent is higher than 1.
Well, because what is the derivative of 2?
something on
Y squared.
So you have to add the
Well,
But you do
when
that with,
when
like,
you power
x2.
down the y, it's like when you subtract 1, it's y to the 0, which is 1.
Wait, what?
But like with x2, you would do like
If we take the derivative of y, right?
Right.
What's its exponent?
1.
So we go power down.
Uh-huh.
This is not a prime, right? This is a 1.
Right. So it would be
It would be 1
1 times
y to the
0.
0,
So it's 1.
which is 1. So the y to the 0.
Oh, so the y becomes a 1, right? Okay, got it.
Mhm.
But in the 2y, the y
stays
stays.
because it's y to the
If
first.
it's y to the third,
It would be 3y squared dy
Oh.
dx.
okay,
If it's y to the
You're
fourth?
just taking y down 1 power,
Yes,
but then you just have to add dy dx at the end.
because you're taking the derivative of the inside.
Okay.
Plugging
I'm
it
gonna
in.
get confused if I keep this.
That's all right.
Why?
I might just
Okay, I got it. I think I got that now, Miss Muller.
Good. I'm happy.
But I only have to put the. Okay.
No,
I got
listen.
It. No, I got it. I'm not
No
saying
question is silly or stupid.
Yeah, guys, stop laughing
Because
at me.
listen, I'm not at all, because Mr. Jones, God bless my Algebra 1 teacher. Because I was a move up then, because I was in pre-algebra and I was, blowing them all away with the fractions and the keep change flip. I was just,
Cruising right through those.
and then so they moved me up, and then of course my head was like, oh my God, why are you doing this? Can you do this? Can you do? You know what I mean? So I get it,
Well, I mean, I'm not a move up and I still like.
but that's all right.
And here the whole time.
So it's okay to ask lots of questions. All right, so there it is. There's the derivative. You okay with that?
I think so.
All right, find the coordinates on the curve where the tangents are vertical.
So,
What does it mean to have a vertical tangent?
it means the slope is undefined.
Denominator equals 0.
So dy dx
Good one,
is
Sam.
undefined, right? For vertical tangents.
So it would just be like 1x equals. Just gonna wait. Julia, I just went for
So that's going to be when the denominator is equal to 0. So we're going to say 0 equals negative x plus 2y, right? So that means x equals what?
Oh, I was right. Okay.
2y. But that's not, they asked us for what? The coordinates.
So you just plug y in, don't you?
Well,
Or
so
plug
this is
x
one
in.
equation. What was the other equation that we started off with? X squared?
Minus xy.
X squared minus xy. I forgot it again. Plus y squared equals 9. So these two things have to be true for you to have a vertical tangent. First, the point has to be on the curve. Do you agree?
I do.
And then you have to have the slope be undefined. Well, the slope is undefined when x equals 2y. So now what can we do to solve this
Plug
system?
in.
Plug it in, right?
Yeah.
So I'm going to, wherever I see x, I'm going to put what in its place?
2y.
2y. So we're going to say 2y squared minus 2y times y plus y equals 9. So we get 4y squared minus,
I think that's supposed to be a y squared.
this is y squared, I'm sorry. 4y squared minus 2y squared plus y squared equals 9.
I thought you.
Right?
Oh, the whole thing's good.
Okay, so then I have
Really good.
4 minus 2,
3y.
I can't relate.
3y squared equals 9. Y squared equals
3.
3. Y equals plus or minus root 3. So now we have to find the points. Well, if I know that x equals 2y, when x is,
Negative 2 or 3.
when y is root 3,
It's 2
x is 2 root 3, right? And when y is negative root 3, the x is,
Negative 2 root 3.
right here are the points where the lines are vertical. All right, now,
Oh gosh.
like, will you please? Now, sadly, we cannot graph implicit graphs on our calculator. I mean, we could, but it's way too complicated. Minus x times y times y plus, right? Y squared, help me.
Yes. Y squared. Yes.
Equals 9. Oops, not 9, 0. Oop, try again, 9. What is that?
Ellipses.
It's an ellipse,
Single petal.
right?
total ellipsis.
Now, so what points did we say? We said we had a point at, let's graph it, 2.
3.
I don't think Miss Muller heard my joke.
I know, I'm trying to get the
She's
content
mad
in.
at us because we're talkative
What was your joke?
today.
being recorded, so it's gonna be out there for all people
See,
to
you
hear.
didn't write that on the test. I did.
You actually wrote that?
Oh.
Yes, a single petal.
And that's your vertical
Single
tangent.
rose petal?
Or whatever. Whatever it is, I don't remember, but I wrote that on a test.
Yeah, that was great. I remember grading that test.
Wait, what did you write on the test?
A single
petal
rose
Oh,
petal
wait.
or whatever.
I think that was my one.
Single petal rose with radius.
Yeah, well, it's what? It's what?
That's what a circle is,
I
yeah.
got this one.
Okay,
That's your question.
now,
Junior year.
how would I come up with the equation of these vertical lines?
When you put it.
Just do
Plug
change in y over
that.
change in x.
What?
Get a slope.
Well, you already have this.
Why don't you just do the y
It's
line?
not defined.
Oh, you plug in the x value.
So you say x equals, oops,
2/3. I mean, 2/3. 2 root 3.
I'm copying and pasting.
Oh.
There it is it vertical there?
That's vertical.
Yes.
Yes.
How vertical?
If I do say so myself.
Okay, I guess
That's
it's not gonna be
vertical, fine,
nice and
if
give
you
me a
want.
nice point, right? And then y equals negative,
No, x.
X equals.
I'm sorry. I put a negative, no I didn't yet.
Control V.
So it works, right?
The colors kind of clash.
Yeah, I'm not really feeling the orange.
Okay, Maggie.
Well, but I'm sorry, that's
I
the
think
way
I think
it
orange
I
is
think it
nice.
looks great.
Somebody's
I don't judge things by their external appearance.
As long as it's the right answer, I'm not.
Is it color?
I don't know.
No, Angel's just.
Yeah, no, I was gonna
Yeah,
say,
I'm
I'm
pretty
pretty
sure
sure
it's
it's
ugly
blind.
because of the
You
color.
can't see
Because it's ugly because. Ew.
He was literally, I have to squint.
So what I guess I'm trying to say is, does this work even for implicitly defined functions?
Yes.
Yes, okay, now, your calculator will do this for you, all right? This is what I wanted to get to, all right? So, what I want you to do is on the calculator, which Trisha's so kind to do, can you move it over to the left a little bit? There we go.
Nice for you every day.
Okay, so, let's, clear that out, and let's do, if diff, no, we know what the derivative is, right? Oh, okay, let's say we wanna solve the system on our calculator, right?
Isn't that under
So what we wanna do is hit solve, which is F2, solve, enter, and now we wanna solve that x squared minus x times y, you gotta use the times here,
Are we gonna have to use the time?
plus y squared equals 0, right? Or it equals 9, I'm sorry, 9. I keep wanting to say 0. Comma, what do we want to solve it for? We want to solve it for y, don't we? Because we knew what x was. So let's, okay, so y, close the parentheses, such that, what did we say x was equal to?
2y.
X equals, we type in x equals 2y. And press enter.
Oh my god.
So did your calculator solve the system for you?
Yes.
I feel like this test isn't gonna be calculator though.
That's amazing, isn't
Wait,
it?
yeah. So wait, do we get to use these on the test?
For half of it, right?
Screw it, bitch.
I didn't know athlete had 3 syllables. It's amazing.
So,
It checks out your register.
your calculator will do some of these, right?
Oh, Miss Mullen.
Yeah.
My sister wanted me to tell you that she got a 108 on her calc test. And so did Michael Holder.
Good
Yeah,
guy.
at 108. So she said it's all you.
Oh, well, that's kind of her, but you know.
Yeah.
Good luck, guys.
Yeah, she's working hard.
Out of 108, so just 100.
So she's
Barnard, so where was she? Is she on my thing?
The rate of change, like of the slope, so saying the rate of change of the derivative. which
Right,
is-
so we have to take, what's the rate of change of the slope? That's the rate of change of the derivative, so we need to find the second derivative. All right, so why are we unhappy? They gave us a point. Watch what happens. It's really nice. So what is dy let's write what dy dx is. You think they're gonna give us these points, right?
Negative.
I'm sorry, what is it? It's
y minus 2x.
y minus 2x over
2y minus x.
2y minus x. All right.
These look so symmetrical.
I know they do. So the second derivative with respect to with respect to x is going to be ho,
Yeah.
which is 2y minus x, right, times the derivative of the top, which is dy dx minus 2 minus hi, which is y minus 2x, dho, which is 2 dy dx minus 1 all over ho, which is 2y minus x quantity squared. Now, I would not go through and plug in this double-decker fraction. Did they give me a point? They did, such that x equals 0, y equals 3, right? It was 0, 3? Let's try again. 0, 3. So let's plug in what we know. X is 0 first, right? So let's get rid of those. That's 0. That's 0. And that's 0, right? That's nice. So now let's figure out what dy dx is at 0, 3. So this is going to be 3 over,
So why are we doing
it's
the
1/2.
first one?
I'm sorry? Why? Because I have to find out what the derivative is at that same point.
Oh, okay.
Right? So when I plug in 0, I get, on top I get 3 over 6, which is 1/2, right? So when I plug in y equals 1/2, we get, dy dx equals 1/2.
Oh, so we can't substitute dy dx as y, no.
You could, but that's going to be messy. They already gave us the numbers. It's going to be easier just to plug the numbers in.
Gotcha.
So 2y is 6, right? Times dy dx we said was 1/2 minus 2 minus y is 3 times 2 times 1/2 minus 1, which something nice just happened there, over, this is 1 minus 1,
Oh, which is 0.
which is 0. So this goes to 0. And then 2y down here is 6 squared, which is 36, right? So I put 3 in here. I get 6. 6 squared, well, right, 6 squared is 36. Okay, this right here, is this negative 3/2? Negative 3/2. Well, but we could cancel one of the 6's before we go, right? Because 1, 0, right? Because this is already gone. So it's going to be negative 3/2 divided by 6 over 1. Negative 1/4 is the rate of change of the slope at So what if I wanted to find out where all the tangent lines were horizontal? We found out where they were vertical. You would set the numerator of the derivative equal to 0, and then you'd solve the system, right? Because this is going to be a little bit different, isn't it? It's going to be y equals 2x. So you take the 2x and you plug it in where the y is. Right?
Right.
So, yes.
Well,
What is that?
Yeah.
I am toasted. I am exhausted. I am toasted.
Up to the
Up to the question?
question.
Oh, I'm so sorry.
Okay, so on A, how do you know that he's asking you about the derivative?
General expression for the slope.
Good morning. Please stand for the morning prayer and pledge of allegiance. If you're in the hallway,